Quickly, we are going to be treating fundamental quantities as requested by some of our students. Now, fundamental quantities are those quantities that other quantities depend on. They do not depend on other quantities, but rather other quantities depend on them. And fundamental units are the units that other units depend on. Are you there? Now, we have about 7. Generally, we have about 7 fundamental quantities and 7 fundamental units. These are listed 6 here. We have length, we have mass, we have time, we have temperature, we have electric charge, we have amount of substance. Now let's check their unit. The unit of length is meter. Are we there? The unit of mass is kilogram, as kg. Time is second. The unit of time is second. The unit of temperature is Kelvin, abbreviated as K. The unit of electric charge is Coulomb, abbreviated as C. While the unit of amount of substance is mole, M-O-L, mole. Are you there now? Now let's quickly check derived quantities and derived units. Now, derived quantity are the quantities that depend on fundamental quantities, while derived units are the units that depend on fundamental units. Do you get it now? Now, to get the unit of a derived quantity, if you combine two or more fundamental units together, you will get a derived unit. Now let's try it now. The formula for area has a length times length now. You get it now? So length times length, that's L times L. What is the unit of L here? L is mass. That's M times M, which is what? M squared. You see that if I combine 2 fundamental units together, it will give me a derived unit. Do you get it now? Good. Now, the same thing goes for volume. Volume is M times M times M, which is what? M cube. That's M raised to power 3. This is the unit for volume, the unit for area. Now, the unit for speed, the formula for speed, please, to get, most of the time for the derived quantities, to get their unit, we go through their formula to get their unit. Although it's not all, but most of them, we go through their formula to get their unit. Speed is what? Displacement over what? Time. If I want to get the unit of speed now, displacement is more like, distance, Distance is, if you are measuring from here to here, is a distance. And when you are measuring, what unit will you use? You are going to definitely be using what? Meter. So, we'll now have what? Meter. What's the unit for time here? The unit for time here is what? Is seconds. So, we have what? Meter per seconds. So, the unit of speed now is meter per second. Are you there? Good. Now, what is the formula for density? The formula for density is mass over what? Volume. The formula for density is what? Mass over volume. What's the unit for mass here? Mass is kg. Kg per volume. What's the unit for? We look for volume here. M cube. So, the unit for density is kg per meter cube. Are you there? Now, let's check for area. Area, the formula for area is what? Velocity over what? Time. Before this, let me do for velocity, so that what we get in velocity, we use it to treat this one. So, now, velocity is what? Displacement over time. Just the way we have it in speed. The same unit for speed also goes for velocity. So, is what? Meter per seconds. That is the unit for velocity. Now, since we now have for velocity here, so we can use this one to replace this velocity at the top here. So, we can have it as to be equal to what? Meter per seconds. Now, this time that is there is also measured in seconds. So, meter per second per second. You get it now? Now, if after solving everything here, you at the end of the day, you now have it as meter per second square. The unit of acceleration is what? Meter per second square. Good. Now, force. That's all. The formula for force is what? Mass times what? Acceleration. ma. That's the formula for force. But yeah, we do not work. We are not working with the formula now. But you remember I said it's not all. But the unit of force here is what is Newton. Sorry, the unit of force is what is Newton. Is it clear? Then work. Work is what? Force times what? Distance. But the unit of work here is what? Is joule. Do you get? Good. Now let's check dimension. Dimension. What is dimension? Dimension shows or tell you the relationship between the fundamental quantity and the fundamental derived quantity using the fundamental unit. Let me go again. It tells the relationship between fundamental quantities and derived quantities using the fundamental unit. Now, what is the main unit, fundamental unit we always use in solving dimension? Now look, I'm going to write it here. Now the main unit is what? MLT. M stands for mass, L stands for length, and T stands for time. These are the three main fundamental quantity. Are you there? Okay, now let's continue. Now we have a question there. It said we should find the dimension for velocity. Dimension for what? Velocity. Please, again, when you are going to look for the dimension of anything, use their formula to derive their dimension. Now, what's the formula for velocity again? We have a displacement over what? Over time. Now, yeah, you now see that the formula, the displacement is also measured in meter. So we have going to be having what? Meter. What is the unit for what? For time? That is what? Second. Are you getting it now? Now, we are using their units now. So let's take this unit back to the quantity. Meter is for length, Abi. So we now have it as what? L. Second is for time. We now have it as what? T. So we can therefore say that velocity, dimension for velocity is what? L T raised to power minus 1. Or you can leave your answer like this, or you leave it like this. This is the dimension for velocity. Is it clear? This is the dimension for velocity. Now let's check the B part. Before that, alright, now we have area on the board. Area, the dimension, what is the dimension for area? Remember the formula for area, when we wrote it here before was L times L. So area is what? L times L. Now, by just looking at it, you already know the dimension. L, this is your length here. So the dimension for area will now be equal to what? L times L will give us L squared. This is the dimension for area. Is it clear? Now, let's check the last one, force. Force, dimension for force. What's the formula for force? Force, according to the formula we gave here, we said mass times what? Acceleration. Now, mass, this one is measured in. The mass inside is what? Is already here. We already have for mass. So this one will now say that F is equal to what? M. We already get for mass. So let's check for, now we are not left with what? Acceleration. So let's bring out acceleration separately now. Let's see. Acceleration, what's the formula for acceleration? We have what? Velocity over what? Time. Do you get it now? Now remember we've already done for velocity. What was the dimension for velocity? That's L over time. So this L over T, we can put it in place of this one. So L over what? T over, now what's this T? This T is also time. That's big letter T again. So big letter T. Do you get it now? So I can also write it as this, like this. L over T divided by what? T over 1. Do you get it now? So to change this side to multiplication, we will take this one up and bring this one down. So we'll now have it as what? Equal to what? L over T times what? 1 over T. Do you get it now? So acceleration now will now be what? L times 1, which is L over T times T with what? T squared. Do you get it now? So now from here now we can replace this area, this acceleration we have here with this. So let me quickly wipe here. Sorry, so that we can solve it. Okay, now we now have it as Remember, area is what? L over T square. You get it now? So, force, therefore, will now be, we have M. In place of this acceleration now, we replace it with what? L over T square. So, we now have times what? L over what? T square. This M will multiply this L. So, we now have it F to be equal to what? ML. Then remember, this M is an invisible over 1, yes, so that's why M will multiply this, 1 will multiply this, now I have 1 T square. This is the dimension for what? Force. Or you can also write it like this, F is equal to ML T raised to the power minus 2. I wrote it in indices form now, so it's still the same thing. If it were to be OBJ, objective question, then if you cannot find this answer there, you will definitely see this one. But if it is just theory, you can do it any way you want. So, in case you are yet to subscribe to this channel, please kindly subscribe. And please, before you go, do not forget to strike that like button. Stay blessed.